This is Euclid's construction of the geometric mean. The phrase geometric mean is not just a modern algebra name. Historically, the mean is called geometric because Euclid actually builds it with geometry. First a midpoint, then a semicircle, then a perpendicular, and finally the required segment. Begin with the two given lengths laid end to end on one straight line. Mark the left endpoint A, the joining point D, and the right endpoint B so that AD is A and DB is B. Everything else in the construction is built from this one line segment AB. Now construct the midpoint of AB patiently. Open the compass to one fixed width larger than half of AB. Draw one arc from A and another arc from B with that same width. Those arcs meet above and below the line. Join the two intersection points with a straight edge. Where that bisector crosses AB, mark the point O. That point O is the midpoint of AB. Next, use the midpoint as the center. Because O is the midpoint, OA and OB are equal. So with center O and radius OA, draw the semicircle through A and B. This is the Euclidean figure that turns the arithmetic data on the line into a geometric object whose vertical segment will become the required mean. Now build the upright line through D carefully. First draw a small circle centered at D so it cuts the baseline in two nearby points. Call them P and Q. Then from P and from Q draw equal larger arcs above the line. Their new intersection fixes the direction straight above D. Join that intersection back to D. The resulting line is perpendicular to AB, exactly the vertical we need. Finally, let that perpendicular meet the semicircle at C. The constructed segment CD is the mean proportional between AD and DB. So this one vertical segment has exactly the length square root of A times B. That is the object Euclid wanted. Not just a statement about numbers, but a line segment constructed by geometry. This video is the construction. For the proof of the formula itself, go back to the earlier proofs. Proof 1 completes the circle and uses intersecting chords. Proof 2 uses Thales' theorem and right triangle similarity. Those two proofs justify why the constructed segment really satisfies CD squared equals AB. So that is the whole point. Euclid's construction shows why the phrase geometric mean is genuinely geometric. The mean is built as a line segment. And if you want the proof of the formula behind that segment, see the earlier intersecting chords proof and the earlier similar triangles proof. Together, the construction and the proofs complete the picture.